morning, friends. I feel immense pleasure to be here for my course, Flight Mechanics. I am in the process of solving some numericals. Today, I will be talking about problem solving on turns of an airplane with numericals. I am Dr. Yagya Dutta Dwivedhi, professor from Institute of Aeronautical Engineering, Department of Aeronautical Engineering, Hyderabad, India. In today's topic, I am going to solve some problems, that is, calculate the minimum time, calculate radius of the turn, calculate the glide performance. These are the few topics which I am going to solve the problems. So now, problem number 1, that is turning flight. An aircraft has the following characteristics: CL maximum is equal to 1.5, S is equal to 125 feet square, W is equal to 2000 pound, N1 is equal to 4, CD is equal to 0.02 plus 0.05 CL square, T is equal to 300 pound for all flight speed at sea level, turbojet engine, and epsilon is equal to 0. Calculate the minimum time aided to perform a constant altitude of 180 turn, assuming that there will be an adequate thrust to perform that turn. The drag coefficient is CD, it is 0.02 plus 0.05 CL square. So now we will see that in this aircraft, in this problem, this is the aircraft. CL is given, area of the wing is given, weight of this aircraft is given, load factor N1 is given, CD drag polar is given, and thrust is given, and it is turning with full half circle from here to here. It is called the 180 degree. So now we will solve this problem. In this case, it is given that CL max is equal to 1.5, area is equal to 125 feet square, weight of this aircraft is 2000 pound, load factor N is given 4, the relation CD is equal to 0.02 plus 0.05 CL square. Thrust is equal to 300 pound at sea level. These are the given parameters. Now we have to find out the CD, because CL is given. So in this equation, we will find the total drag coefficient, that is the CD, is equal to 0.02 plus 0.05 into CL is 1.5 square. So this CD you are going to get 0.1325. Now I will change the other color. We have to find the stall speed, and stall speed is, we know that Vs is equal to under root 2W divided by rho S and CL max. So here W is given 2000 pounds divided by rho is equal to 0.002377. It is in slugs. So now 0.002377, area is 125 and CL is 1.5. So you will get this Vs is equal to 94.7 feet per second. So we know that the corner speed VC is equal to Vs under root N1. Vs we have find out 94.7 into under root 4. This you will get 190 feet per second. So this we got the corner speed. Now we know the time. So we will find the time for minimum turn. So that is the T minimum is equal to psi Vc divided by G under root N1 square minus 1. So it is pi 180 degree into 190 divided by 32.2 G 4 square minus 1. So you will get this one 4.79 seconds. So now, checking now, velocity of adequate thrust. So T1 is equal to psi, this is half rho V square S into CD. So half 0.002377 into 190 square into 125 into 0.1325. Thrust we will get 710 pound. So now if you see that this thrust exceeds the given value of 300 pound. So in this condition, that is at 4G, turn not possible. Turn not possible. So what is actually possible is, n under root 2 T by W minus 1. So here we will see that 300 divided by 2000, W is 2000, T is equal to 300, and minus 1, we will get 1.934. So this is the load factor which we are required to get. Now, in order to calculate the flight velocity, the turn lift coefficient, that is CLT, is equal to N1 under root CD naught by K. So this is, we can write N1 is 1.934, CD naught is given 0.02, K 0.05. So we will get 1.22. So this is the coefficient of lift for this, and the turn velocity Vt is equal to under root 2 Wn1 divided by rho S CL. So we will get here 2 into 2000 weight, N1 is 1.934 divided by 0.002377 rho, area is 125 into 1.22. This will get 146 feet per second. So this is the velocity which we supposed to get it. So now we will see the further that we can see here that now the bank angle, now the bank angle phi, we can write that tan phi is equal to under root nt square minus 1, 1.934 square minus 1, 1.655. So this phi is equal to 59 degrees. So this is the turn angle or bank angle. Now time to turn, that is the t, is equal to psi v divided by g tan phi. So this is 146 into v pi divided by 32.2 g into 1.655. You will get 8.59 seconds. So this is the time. Now turn radius r is equal to v square divided by g n square minus 1. V is equal to 146 square, g is 32.2 under root 1.936 square minus 1, 399 feet. This is the radius. And lift coefficient CL, in this case 2Wn divided by rho s v square, 2 into weight 2000, n is equal to 1.936 divided by 0.002377 into 125 into 146 square, 1.22. So now the flight speed is reduced. Flight speed is reduced, and this VL is equal to 2W rho S CL, 2 into 2000 under root and 0.002377 into 125, you will into 1.22, you will get this VL is equal to 105 feet per second. So we can find out the thrust T is equal to half rho 0.002377 into 0.944 into 125 into 105 square, you will get 155 pound. So this is the answer for this problem. So now I will go for the problem number 2. The aircraft in above example is in level flight of 125 feet per second and set out to perform the same 180 turn but keeps the flight velocity constant while turning. This, however, requires that the lift coefficient be increased to maintain altitude and to produce turning acceleration. Thus, the drag coefficient also will increase with an increase in. So, we will see here that in this also the given CL max is equal to 1.5, S is equal to 125 feet square, weight is equal to 2000 pound, and T is equal to 4, CD is equal to 0.02 plus 0.05 CL square, T is equal to 300 pound. So we have to find out the first term. Time T, we know that V into psi divided by G under root n square minus 1. So where n we can find out in this case V psi divided by T into G square minus 1, and if we calculate this 125 into 11 divided by 8.59 into 32.2 square plus 1, it is plus 1. So you will get n is equal to 1.74. So required CL and CD. So CL is equal to 2 Wn rho SV square. 2 into weight is 2000, N is equal to 1.74 divided by 0.002377 into S is equal to 125 and V is equal to 125 square. So you are going to get 1.5 and drag coefficient CD is equal to 0.1325. So thrust required T is equal to half 0.002377 into 125 into 125 square, 307 pound, and the resulting turn radius R is equal to 125 square divided by G into N square minus 1, 1.74 square minus 1. So this R you will get 340 feet. This is the answer for this problem number 2. Now we will see the problem number 3. Consider a light aircraft with the following characteristics. Weight is equal to 3000 pound, S is equal to 220 feet square, CL max is equal to 1.2, H is equal to 5000 feet, CD is equal to 0.025 plus 0.06 CL square. The aircraft is in a 45-degree steady bank gliding turn. Calculate the glide performance for one full turn. So now we will see for this. We will first write the given parameters. Given parameters are weight W is equal to 3000 pound, area S is equal to 225 feet square, CL max is equal to 1.28 5000 feet, CD is equal to 0.05 plus 0.06 CL square. So we have to find out the turn radius and other thing. So now we will start solving this problem. So first we will see the glide angle. Gamma is equal to tan inverse 1 by EM. So tan inverse 1 by CL by CD. EM is CL by CD. So we can find out here the CL also from here, and CL by CD you will get 12.9. So 12.9, and this here you will get 4.43 degree. So this gamma angle is 4.43 degree. So during bank we assume CL is equal to CL max is equal to 1.2. So in this case L by D is equal to 8.8. So now CD is equal to 0.025 plus 0.06 1.2 square. You will get here CD 0.1364. So here we can write that cot gamma is equal to 8.8 into 0.707. It is equal to 6.22. So here gamma is equal to 9.13 degree. Another case. Now velocity V is equal to, we know that 2 into W sine gamma divided by rho S CD. 2 into W is 3000. sine 9.13 here, this is the gamma here, divided by rho 0.002377 into 0.8617 into area is 225 and CD we have got 0.1364. So this velocity we will get 120 feet per second. So now we got it. Now we have to start for the radius of the turn. So radius of the turn R is equal to V square cos of gamma G into tan of phi, and if you put this value, all this V is given, gamma, G and all, you will get 464 feet. So this is the radius of this thing, and the loss of altitude. The loss of altitude is in one complete turn is S phi is equal to pi into R into tan of gamma 2 into pi R is equal to 464 tan 9.13 degree. You will get this as a 468 feet. So this is this much it will fall down on this system. So for the next lecture, we will be discussing your revision of takeoff and the landing, minimum control speed, calculate ground roll, thrust required for a takeoff and the ground roll. These are the references which I am going to take. Anderson Performance and Design International Edition. Next is SL by Aircraft Performance Theory and the Practice, AIA Education Series, AIA. Any questions you can ask to me in yddwivedhi@gmail.com. Thank you very much. Be tuned for my next lecture. Do like and subscribe.
Like, share and subscribe. Hit the bell icon for more updates.